Geometry, section 3.1, part 2. We're going to kind of pick up where we left off on this little slide here. Just a reminder that the abbreviations are what we're leaning towards, what we're moving towards, and we will use some of them today in proofs. We're actually going to do 5 proofs in this lesson. This lesson could get a little bit long. If you've got to stop and process, if you got to take it in 2 parts, that's fine. Just use the pause button. But again, just as a reminder to pick up where we left off, this says parallel lines implies corresponding angles are congruent. This says parallel lines implies alternate interior angles are congruent. The letters are important. There's only one letter difference between these two, interior and exterior. You wouldn't want to use the wrong one. There's only one letter difference between these two, interior and exterior. Okay? And we're going to prove some of these today. The other thing that I need to point out to you on this slide is that as I presented them to you, so are they given. Okay, the order of these matters. The corresponding angles postulate came first. Remember that a postulate is not something that can be proven. It's an accepted fact. A postulate is just true. Okay, we had a postulate before that said right angles are congruent. Okay, well that's just true. They're both 90 degrees. The right angles are congruent. So this is the case. Once we have one, then we can prove the rest of them using the postulate. So that's why the rest of these are theorems. Okay. That being the case, along the way here, we're going to prove this one. Okay. On my Starboard software, we will be proving this theorem. That means that the corresponding angles postulate is already given to us. We'll prove this one. Now you can't use this one to prove this one, but we'll prove it using prior things, like think of like vertical angles and right up to and including the corresponding angles postulate. Okay, you can't use any of these either because they're coming later. So you got to kind of think of this sequentially, right? As I presented them to you in the last video, this is true, and then we'll prove this, and then that's true, and then we'll prove this, and that's true. I'm not going to prove all of these. We're going to prove 2 of the 4. And as I prove this one, remember that this is at our disposal. The rest of them are not. Okay, so first of all, we're not there yet. Look at a couple of examples. There will be one proof in these examples as well. Right here, it says use the given that A is parallel to B. That's line A is parallel to line B. That's what that says. And the diagram to write a 2-column proof that angle 1 and angle 4 are supplementary. Now, as we get started here, I need to say this, that we only do 2-column proofs. Okay, I'm going to introduce to you what a 2-column proof is. We're going to do one right now, and we're only going to do 2-column proofs. If your textbook ever says write a flow proof or write a paragraph proof, you're going to ignore that word and you're going to write a 2-column proof. No flow proofs, no paragraph proofs. We only teach this one way, and it's with 2-column. Okay, now again, the given is this. Here's the way we start. We always start with a big long T-chart and the word statements and the word reasons. I'm going to have this in notes here in just a second, but let me just do one for you here first. And the given is this. A is parallel to B. So we always list that first, and we say given. Now stop and think about this. You haven't had to think about this diagram at all. All you had to do was draw a T-chart, write the word statements, write the word reasons, write a number 1, and write what's given here, and then justify that with given over here. And then you can write number 2 and number 2. It's important that you label your lines. Okay. The point I'm making right now is you haven't really had to think at all. You haven't had to do any geometry yet. Everybody should be able to do this right now. Big T-chart, statements, reasons, write number 1, say what's given, use the word given, write number 2. Okay. And then we need to use some of the things we know. And as I look at the picture here, I'm going to mark it as parallel, line A and line B. We want to show that angle 1 and angle 4 are supplementary. Well, we don't know that yet. Not only that, I'll point out also that 1 and 4 are not any classification that we have learned, right? They are on opposite sides of the transversal. One of them's exterior and one of them's interior, right? So this doesn't fit into any of the 5 classifications. Here's the question. What 2 angles could we say that are supplementary? You can't jump right to 1 and 4, but wouldn't you be able to say like angle 1 plus angle 2 is supplementary? Or angle 3 plus angle 4? Let's say that. Let's use angle 3 and angle 4. The measure of angle 3 plus the measure of angle 4 equals 180. Okay. Now, again, we're going to give you a half sheet. I'm not sure you'll be in possession of it yet as you watch this video, but shortly it's coming, and it's going to have a bunch of abbreviations on it. And one of those abbreviations is going to be the definition of supplementary. Don't you see that these two angles form a straight angle? Okay. So this abbreviation is on the sheet. And if I haven't given it to you yet, maybe it's time to remind me to give you the half sheet that's got the abbreviations on it. Definition of supplementary, and we have this abbreviation, or maybe it's definition of supplementary angles. Now that I think about it, I don't have one in front of me right now. That's true. And 3 and 4 are supplementary. What else would we know is true based on something we learned in the previous video? Well, wouldn't you know, for example, that angle 1 is congruent to angle 3? Angle 1 is congruent to angle 3. Those are corresponding angles. Now, not all corresponding angles are congruent, but we started out with a given that these lines are parallel. Since the lines are parallel, these corresponding angles are congruent, and the abbreviation looks like this. Parallel lines implies corresponding angles are congruent. There's never any reason to deviate from these abbreviations whatsoever because we give them to you. We give them to you for the homework. We give them to you on quizzes and tests. This is going to be the case all the way through chapter 4. 3 and 4 deal with proofwriting, and these are the things we're going to give you. Now, stop and think about this. What can we do? We're trying to show the angle 1 and angle 4 are supplementary. By the way, in my world, what this should say is the measure of angle 1 plus the measure of angle 4 equals 180. This is what we're really trying to prove. And I believe we're there right now. We're ready to say that. The measure of angle 1 plus the measure of angle 4 equals 180. Why? Well, the reason is substitution. If you know that 1 and 3 are congruent, then you can replace 3 up here with 1. It's substitution. Again, angle 1 and angle 3 are congruent. Here you have angle 3. I can replace it with angle 1 because I know they're congruent. That's a substitution. Now, I know in chapter 2, I would say substitution property with the equal sign here because it was the substitution property of equality. Do you notice that we're substituting a congruence statement in for an equality statement? So for that reason, I'd usually just leave off the symbol here. Here you had congruent because this says parallel lines implies corresponding angles are congruent. Here I'm just going to call it substitution property, be done. Okay? Because it's not really the substitution property of congruence or of equality. All right, so that was your first proof. Give yourself a pat on the back. That's your first proof. Hopefully you understood that. We're going to do 4 more in this video. Now, as you saw, this is the basic outline of a 2-column proof. Statements, reasons, that's R-E-A. And basically, the format is you're going to write what's given first. You're going to say that it's given. Sometimes it's more than one thing. We're going to see that today as well. And then you can write number two, and it just goes as long as it goes. I think the longest proof we've ever done in class was over 10 lines. The shorter ones can be 2 lines. But they're all in 2 columns, and we just go until we've proven what we wanted to prove. Okay, so an example. Oh, you know what? I wanted to do another. I'm a little out of order here. I wanted to do one more example here before we get really into the proofs. Find the measure of angle 1 and then the measure of angle 2. Notice that this has nothing to do with proofs, right? It does have to do with corresponding angles, right? So angle 1 and the angle that's 42 degrees. Wouldn't you know that the measure of angle 1 is 42 degrees? Because the lines are parallel. The lines are parallel, so corresponding angles are congruent. So angle 1 is 42 degrees. What I'm saying is no proof. There's no justification to be done here. We're just asking. They're asking a different question here. Then wouldn't you know that the measure of angle 2 is a sum with the 42 degree angle here of 180. So wouldn't that be 138 degrees? Yeah, we just want to get that one out of the way before we go ahead and really tackle the proofs hard. So here we go. All right, now we're going to prove the alternate interior angles theorem. Now, once again, that was the second theorem that I gave you in the previous lesson. So we have the first one. The corresponding angles postulate is there for us. You can't use this theorem to prove this theorem. That's what my old geometry teacher called a bootstrap. I'll tell you that story in class at some point. And so we can't use that, and we can't use any of the theorems that come after it. You got to think of this in the order that they were given. So we want to, and I've kind of just picked this out. We want to take the given that L is parallel to M and prove that angle 3 is congruent to angle 6. Those are alternate interior angles. This isn't any special picture. This is just some generic picture, and 3 and 6 are alternate interior angles. If we can prove that they're congruent, great, then we can use that theorem. Then it's a theorem and we can use it. Once it's been proven, that makes it a theorem. So what you do is you make yourself a wide t-chart. This is not a t-chart like in Algebra 1 where it's thin and you're just putting values in for x. We need space to write, so make it nice and wide on your paper. Number 1, we're going to say L is parallel to M. And we're going to justify that with given. Always start with your givens. And mark the diagram so. You're going to help yourself a lot if you mark the diagram. So what's true, and what you want to do is kind of think of the goal, the end goal in mind. We want to show angle 3 is congruent to angle 6. Now, I can't jump right to that because, again, we don't have the alternate interior angles theorem yet. But what would I know are congruent? What angles would I know are congruent? And you might as well use either angle 3 or angle 6 to kind of give yourself the right direction to start. Wouldn't we know, for example, that angle 3 is congruent to angle 7? Now, let me say again, I know this can be confusing. Where we are in the sequence of yesterday's notes is right here. We have this theorem. We don't have any of these. We're trying to prove this one. So angle 3 is congruent to angle 7 because parallel lines implies that corresponding angles are congruent. I don't want this video to get too long, so I'm not going to stop just so you can think. If you want to stop and think, pause it. What else would we know? Wouldn't you know that angle 7 is congruent to angle 6? That's vertical angles. This is how we're going to abbreviate the vertical angles theorem. That will also be on your sheet. Angle 7 is congruent to angle 6. And we're trying to prove that angle 3 is congruent to angle 6. And you can see on the picture now that they are congruent. That does not mean you're done. You need to say it. You need to say angle 3 is congruent to angle 6. And again, pause the video if you'd like to think about this, but what would you justify that with? I know 3 is congruent to 7. I know 7 is congruent to 6. I have concluded that angle 3 is congruent to angle 6. Some people will say substitution. I get it. I agree with that. You can say substitution. To me, it actually feels more like the transitive property than substitution, so I will accept either one here. If 3 is congruent to 7 and 7 is congruent to 6, then 3 is congruent to 6. Transitive property of congruence. And you're done. See, you wanted to prove this. You did, so you're done. Let's move on to the next one. Let's prove the same side exterior angle theorem. So again, now we've proven this one. It's a theorem. We can use it now. Let's say we proved this one. It'd be much like that one. And we proved this one. Now we're going to prove the same side exterior angle theorem, the fifth and final postulate / theorem that I gave you in the previous lesson. I'm sorry if I keep saying yesterday. I mean the previous lesson. So again, what do? You got to get in the habit of this. L is parallel to M. You write the given first. You say given. You mark it on the diagram. Now, what do you say about angle 1 and or angle 7? Okay. We can't prove it using the same side exterior angle theorem because we're trying to prove that theorem right now. But angle 1 and angle 7, could you say something else about one of those angles and make it a supplementary statement? How about 1 and 3? The measure of angle 1 plus the measure of angle 3 equals 180. That would be the definition of supplementary. I used that earlier. Supplementary angles, I believe, is the abbreviation. I'll have to look that up to be sure. I don't have the sheet in front of me, unfortunately. Then what? Oh, and incidentally, we don't have a way of marking supplementary on a diagram, so there's really nothing to mark on that line. But then wouldn't we know that angle 3 is congruent to angle 7? And you see why I brought that in? I have this statement, 1 and 3. I'm looking for 1 and 7. So I'm looking ahead and I'm thinking, hey, 3 and 7 are congruent, and I could replace one with the other. That's the next two steps. Angle 3 is congruent to angle 7 by parallel lines implies corresponding angles are congruent. Do we keep using the same thing? Yes. Do we have to? Nope. You could have, now that you have the alternate interior and alternate exterior theorems, there's a few different ways that you could tackle this, but probably the most common way is the way I'm doing it right now. And then line 4, we could substitute 7 in for 3. Now, just to be clear, on the last one, I used the transitive property, because if you have A is congruent to B and B is congruent to C, and you conclude A is congruent to C, that's the transitive property. Here it must be substitution, because it's not the transitive property. You're taking 7 and plugging it into this statement, this sentence, for 3. So it must be substitution. This is going to say the measure of angle 1 plus the measure of angle 7 equals 180. Substitution property. Okay, now again, you get it? On this line, I rewrote this line, but I replaced 3 with 7 because 3 and 7 are congruent. I can do that. 3 and 7 are congruent, so I'm plugging 7 right there and rewriting that line. And that's what we wanted to prove, so you're done. 2 more. So those were theorems. These are not necessarily going to become theorems, although when you prove something, it does become a theorem. It's just not something of note that we're going to put in our book. And start the same way. L is parallel to M. A is parallel to B. You can put them on the same line if you like, then you only have to justify it with the word given one time. If you put it on line 2, A is parallel to B, then you should say line 2 given again. I've seen it done both ways. And we want to prove that angle 1 is congruent to angle 11. Now look, here's angle 1 here. Here's angle 11 way over here. These are not any classification. 1 could be classified with any number of angles at this intersection or at this intersection, but not jumping all the way over to here. So for example, and I just want to do this quickly, angle 1 would be congruent to angle 7. Angle 1 is congruent to angle 7. Why? Well, look at where they are. Aren't those alternate exterior angles? And because the lines are parallel, oops, I forgot to mark it. The lines are parallel. When you have 2 sets of parallel lines, I'll mark A and B this way, and then L and M I'll mark with 2 arrows like this to show that they're parallel with each other, but not the other 2. Angle 1 is congruent to angle 7 because these parallel lines imply that these alternate exterior angles are congruent. Parallel lines implies alternate exterior angles are congruent. Okay? And then look, angle 7 would be congruent with angle 11. Why would I bring angle 11 in? Because it's in my prove line. Angle 7 is congruent to angle 11. That is, parallel lines implies corresponding angles are congruent. Are there other ways to do this? Absolutely. Absolutely. You could use corresponding angles a couple times and vertical angles, and then you'd use the transitive property twice, I believe, so you could make it a lot longer. I think this is the best, most efficient way to do it, as I'm showing you right now. And now, just like the proof that are 2 above this one, the proof that is just 2 above this one that we just did, angle 1 is congruent to angle 11, and this would be substitution or the transitive property of congruence. I like the transitive property. If 1's congruent to 7 and 7's congruent to 11, then we conclude that 1's congruent to 11. Okay? One more. Oh, by the way, you have to say it. Again, you said 1's congruent to 7 and 7's congruent to 11. It shows on your picture now that they are congruent because you got that single arc mark on both of them. You need to say, though, what the prove line wants you to say. So you need to take another line, and it's the transitive property that justifies that. Lastly, L is parallel to M. And A is parallel to B, which is given. I'm going to mark that true on my diagram. And now we want to show that 7 and 16 are supplementary. Angle 7 plus angle 16 adds up to 180. Okay? Now again, where do we go? Well, here's where my thoughts go. Angle 7 and angle 11 are congruent. Not the measure of. angle 7 and angle 11. Does it have to be 7 and 11? No, it does not. But this is what I'm going for. Okay? And that would be parallel lines implies corresponding angles are congruent. Now, again, there are two pairs of parallel lines here. Please understand, these two angles are congruent because L and M are parallel. These two angles don't have anything to do really with A and B, right? They're not even touching A. So L is parallel to M, B is the transversal. That makes 7 and 11 congruent because L and M are parallel. Parallel lines implies corresponding angles are congruent. Then we could say 11 and 16 are supplementary. The measure of angle 11 plus the measure of angle 16 equals 180. What's that about? Well, we just got done proving up here the same side exterior angle theorem. Same side exterior angles have a sum of 180, right? And now that we've proven it, we can use that, and that's what these are. 11 and 16 are same side because they're on the same side of M, they're on the bottom, and they're exterior because they're exterior to the parallel lines A and B. So we say parallel lines implies same side exterior angles have a sum of 180. What parallel lines? A and B. A and B are parallel. M is the transversal that forms the angles 16 and 11. So A and B being parallel implies that those same side exterior angles, 11 and 16, I'm not marking them because, again, I don't want you to think they're congruent. They're not. They're supplementary. 11 and 16. What do you do with that? Well, again, there's a substitution that happens because of this line. I can plug 7 in for 11. And then we would say the measure of angle 7 plus the measure of angle 16 equals 180 by substitution. Not the transitive property this time. This must be substitution. Okay, and I know that was a lot. You could probably revisit this video later when you want to review proofs, but I think this really gets us a good start into proof writing. Thanks for watching and staying tuned to the end. Bye.